So today we're talking about JdbcTemplate. Okay, the one of the oldest pieces of code that I know of from the Spring framework itself. It's not a side portfolio project. It's part of the original. What some people have likened to Batman's utility belt in software development. And this was actually my gateway into Spring framework, like way back when. I actually used to work at Harris Corporation, many moons ago, and um, some people don't know this, but one of the founders, Keith Donald, he actually had also worked at a certain point in time at Harris Corporation, and so that's why he was also in Melbourne, Florida at the time. And um, so there were other people in the area that were working for Spring, and I managed to lure one of them in to give a brown bag presentation at Harris Corporation, and the guy made a presentation about JDBC template, and I looked at that and it's like that is totally cool. So why don't we dive in and start making something with Spring Data? Not Spring. We've been doing a lot of Spring Data, so I just say it naturally with Spring JDBC. So we're going to jump over here and build an absolutely new project, and we're going to use just nothing but JDBC templates. So, and we're gonna build our favorite payroll app. I'll have so much fun building this app so many times. Let's call this Spring JDBC, and it's an example. Now I'm going to go in here and use, in this case, Java, and I'm going to use good old Maven for doing this one, okay? And we'll give it a nice name here about payroll Spring JDBC example. It's not hypercritical what the package is for a demo app, for example. Um, and then I'm going to hop to it here, and first of all, I'm going to make sure, let's check what we got. The latest stable version of Spring Boot right now is 3.4.2. I can go up and get some of the snapshots if I wanted to, but let's just stick with something simple. And I'm going to grab JDBC. Now, right here, I'm going to use the JDBC API. I'm not going to use Spring Data JDBC. If you want this one, you can go check the playlist for Select Star. We've already done an episode on that. Felipe and I both tackled that one, so I'd say go check it out for fun. And we're going to pick Postgres because what CockroachDB speaks is Postgres wire protocol. And Postgres is kind of emerging as a sort of an industry standard for API because it's not the only tool out there that's hanging itself on the Postgres API. So the upshot of this is we get to leverage popular tools like Spring Boot sitting on top of Postgres very easily. Now, on top of that, we're also going to build a very simple, maybe an API layer to go with it. So I'm just going to go grab Spring Web. This is the module that lets us get Spring MVC, or what's called Spring MVC, which is another piece of the Spring framework. And I'm going to hit the create button. So what it's doing, it's making a whole new window, which means that window you just saw from IntelliJ IDEA popped away and stopped sharing. So I'm going to have to go in here and reshare the new screen that it made. I could try to share a whole window, but that gets even more complicated. Okay, I believe this is the one we want. And here we go. Let's I got some old pop-ups here. We don't need this stuff. We do some load testing in some of our training where we beat the heck out of the system with using JMeter, but we're not here to do that today. So this is our fun little app that we just built. It's an empty app. You may recognize this package name that we put in here. If I scroll down here, we can see we're hanging out today. We're just using Java 17, an LTS version of Java, and we've got a Spring Boot starter here for just plain old JDBC and for web. And then here's our Postgres driver. And just in case you didn't know, by default, there's this starter for testing that gets included. And we have another episode of the Select Star show. It's just kind of focused on Spring Boot in general. So if you want to learn more about it, check that out. And if I go over here and take a peek at the left-hand side and look at our dependencies, you can see all these boot dependencies here. And then down here, these are just Spring modules. So you can see Spring JDBC. Oh, I think I can click on it, make it easier to see. Spring Web MVC. And that's about it. And then all this other stuff, there's a lot of test stuff here for us. So part and parcel, this is it. This is what we have to work with. It does, at first glance, maybe it doesn't look like much, but it's actually packs a punch. Now, what I want to do is get a bit of this app put together, and then we can pause and reflect on what we've got here. So far we have our Spring Boot application. This is our entry class that we can run, this public static void main that we run it and the app will start up. But before you run anything, we need to do a little bit of setup here. Now I have some notes off to the side, which is where I'm looking to get the stuff. So one of the first things to know is by default, the port number, the servlet port that Spring Boot's going to operate off of is port 8080. But if you've installed CockroachDB locally, which I have, because if you're going to be a Cockroach employee, you need to have a copy of it. Port 8080 is used by their UI, their database management UI tool called DB Console. So I need to change the server port to something else. I'm just going to flip it to port 8000. And Felipe's got some notes here he's putting up on the screen for us so you can help visualize some of that stuff. Now, there's another setting we do, and I've mentioned it a few times in some previous episodes of Select Star that we need to cover. And it's what does the app need to do when you start up? Now, Spring Boot's got some modes that it does. For example, if you're using something like H2, which is an embedded database, or you can use H2 bigger than that. Most people are using it that I'm aware of as an embedded database. You also have HSQL or hypersonic SQL. Those are dubbed embedded databases. It operates with you. You don't have to start up a separate server for it to run. If you use either of those, Spring Boot's auto configuration will spot that and launch in an embedded configuration. And the embedded configuration says, drop the schema, drop and create the schema. Basically, it'll run your schema initialization scripts, which, something you don't do in production, but the people that are using embedded typically have some kind of either it's a demo app or they're running it for test purposes, which in both those situations, they typically want to scrape and load the database structure. However, if you use something like Postgres driver or MySQL driver or Oracle driver, something like that, it assumes you're probably in production mode. So don't drop the database, right? So the fact is, we're doing a demo app right here. I want it to do the process of drop and recreate the schema. But when Spring Boot looks at the system, it says you're using Postgres. We're going to assume you're in production mode. So I need to tell it, no, I'm not in production mode. So I'm going to go in here and configure the property setting to tell it not to do that. So what I'm going to do is there's a property setting called init mode. And you can't see it through the streaming software, but I got a pop-up here offering me three options: always, embedded, or never. So I'm going to pick always. Got another window that's popped up and gotten in my way. Let me pop it out of my way. Okay. Now, what this is going to do, it's going to let us stop, and when it starts up the app, it's going to look around for two files. It's going to look for a schema file and for a data file to run. And so in this situation, I want to configure the schema, so I'm going to go create a new file. Let me create a schema.sql file. And this is where I'm going to put the definition for my database schema, because let's be clear, this is not Spring Data or JPA, Spring Data JDBA, Spring Data JDBC, or Spring Data JPA, which has the potential to go create our schema for us based on the table structure, or based on the entity type structure that we have. It doesn't have any of that, okay? We're basically taking full responsibility by using JdbcTemplate. So I'm going to need to come in here and define the whole structure. So I'm going to create, in our nice little payroll app, I'm going to drop the employee table that's already there and just recreate it from scratch. And here I've got three fields: an ID, a name, and a role. Now in this case, we're using UUIDs because this is a greenfield. Let's just say it's a greenfield project, and a recommendation in a distributed database is to use a UUID. Now, Felipe, do you know why we prefer UUIDs in distributed databases compared to, say, these monotonic counters that we always hear about using with traditional databases?
Yes, normally, because now we are in a distributed environment. Imagine if we do the serialization like a serial numbers, try to comply with maybe some of the nodes and tell them, hey, yeah, I have the number two, and maybe one of the nodes already start reading a different number. So probably they're going to lose that kind of a sequence. So it's going to get complicated, right? So of course the best approach will be to get into the UUID.
Yep, that is perfectly correct. And then there's this also this added thing where if you're creating a number right after another, what CockroachDB is doing, it's taking your table and it's chopping it up into these chunks. We call them ranges, and then it takes each range and spreads it across the enterprise. So the first range may go to San Francisco, and the second range may get distributed to New York, and the third range goes to London, maybe because that's where your cluster is spread across. And the other thing is, well, you've spread it across three nodes, but what if rows one, two, and three they're going to be sorted together? Those are going to all end up over in San Francisco. And suddenly the load, if you're looking for those three rows, it's going to route all the traffic to that one node. So instead of spreading the load across all three nodes by a randomized UUID naming system, you're going to create what's called a hotspot and force all this action on that node. And you're making it worse because where's rows the next 10 rows going to go? They're going to line up, if it's a sequence counter, onto that same range. So anytime you're forcing unnecessary traffic into a single server or single node or a single range, we call it a hotspot. So if possible, you want to use UUIDs because then first of all, you don't have to go to a central place that's even managing a sequence counter. So instead of maybe you're in the San Francisco node, but the sequence counter is over in London, you don't have to go coordinate with that sequence counter. You're like, hey, I can generate a UUID right here. It's locally generatable. And we looked that up. That's a real word, generatable. So I can generate it right here. I can insert it. It will go to the correct range. It'll randomly distribute it across the enterprise and then avoid hotspots. So we're going to do that. We're going to use a UUID here. And so with that in place, I'm going to add a few more property settings. One thing is I need to configure my JDBC data source settings. So that's how I can type so fast is I got a copy of notes next to me. I'm not a super fast typer. So we're going to feed it. See, in this case, if you use for Spring, so in Spring Boot, the Spring.DataSource properties are used to feed creating a data source bean that will get registered in the app context with these attributes. So here it's just a good old JDBC connection string. In this case, we're telling it which protocol to use, Postgres. Host name, this is the standard port CockroachDB runs on. I'm not running a distributed cluster. I'm running a cluster of a single node, but it works just the same. And then I got the name of the database here. And in fact, this is an unsecured cluster. All right, no phone calls during select star. Okay. And then I actually have SSL disabled. This is not the format to run it in production. Do not run without security in production, okay? You've been notified. And then it happens to have a username of root and no password. Now, there's something else I'm gonna add in here. You may not know it, but if you use any form of whether it's Spring Data JDBC, Spring Data JPA, or just Spring JDBC, JdbcTemplate like we're using today, Spring Boot is going to create and activate a data source connection pool on your behalf. In this case, actually, Hikari connection pool. It's a very popular tool out there. It's very efficient, has lots of good settings, and very effective. And you can run with the default settings for a bit for demonstration purposes and stuff. But here I have some pre-baked parameters set. I'm not going to go into them because it's not hypercritical for our non-production grade performance needs. And then the last bit is when I'm building any kind of demo and trying to gain insight, I like to dial up what I call the nerd knobs and put in some heavy duty logging stuff here. So in this case, I want to do trace level logging for the JDBC calls and for the surrounding transactions that are going to happen as well. All right, now we built this schema. That almost sounds like a parody song. We built this schema. Okay. So I'm going to create an entity. I'm going to create an entity type that matches this. Now I just said entity type. We're not doing JPA here today, but it's still an entity type. The concept sticks. Oops, let me hit the correct key combination. So I'm going to create an employee class. to map this. And then let's capture the properties. So we need, all right, so we have 3 attributes. You notice, have you seen an annotation anywhere? No, because there's no Spring Data here and there's no JPA here. Now what I'm going to do is I'm going to create a bare bones constructor for all the properties. All right. Now this is how to res up an entity, an instance of an entity. If I have all 3, if I have both if I have an ID, a name, and a role. I can't say both. That's an attribute of 2. Okay. So if I have all the properties, I'm going to use this constructor. But sometimes I don't have an ID yet. Instead, there's no ID because I haven't saved it yet. So I like to capture that as a separate constructor call. So just a name and a role. And actually, I'm not going to do that. Instead, what I can do is delegate it to the other one. And then in case I need it, I'm going to make a protected version of this. Well, I may not need that. I may have some legacy stuff left over in my notes. So with this in place, I'm going to go create the getters and setters. And this is where I love to let the IDE do it for me. Now, for any properly designed POJO, we need to create our equals and hash code operations. And again, you can't see it because it's not showing up on the pop-ups. But here's an equals and hash code that my IDE generated on my behalf based on these 3 attributes. So this is how to tell if 2 given entities are exactly the same. And then let's just make a toString method using those same properties. I'm going to flip it to, let me put my different formatter on it. Okay. Okay. So, okay, is everybody dizzy? Okay. So now I've created an equals, a hash code, and a toString method. So we are operational here. We have an entity type. I shouldn't say we're operational because we don't have everything in place. Now what I'm going to do is I want to start using this type. So I've defined all the connectivity settings I need to hook into the database. I've created my entity type. What I want to make is I'm going to use a repository paradigm here. So I'm going to create an employee repository. But here's the thing. This is not Spring Data. So I'm not extending any JPA repository or CRUD repository or other definition. Instead, this is it. So the first thing I need to do is I need to tell Spring Boot, hey, you need to res up an instance of this thing. And what this thing best fits is, in my opinion, in this situation, is I'll call it a service. It's basically a service. And what I want is a JDBC template. And let's create that in the constructor call. Now, in this case, I actually grabbed what's called named parameter JDBC template. So once long ago, there was plain old JDBC template, and it provided some key operations. We'll go see what those are in a minute, but that actually was before even Java 5. It didn't have annotations. Back then, JDBC really only supported using positional parameters. And so that's all that it did. It was very simple. Since then, named parameters have entered the lexicon as an option to use. Support for things like like Java 5 brought forward annotations and some other stuff with it, and so on. So now my favorite, if I go open this thing up, it's going to lead us to this is an implementation of a interface definition where we can see our various operations. And some of the stuff that this thing also has support for is things like generics. We can have generic type management in here, which again, when JDBC template was first created way back when, we didn't have generic arguments. So we're going to see how to leverage that in a little so we build out. Let's build out an operation. Maybe the first simplest thing is if we're going to load data in it and use the system, we need to be able to save an entity. Let's add an operation to build to save something. So now when I created we were talking about these two, the tale of two constructors. We talked about you either have the ID or you don't. That right there can be a good disambiguation for what we're going to do. So I'm going to put a check here. Let's see if somebody hands us an employee object, and if I fetch the ID, and what if it's null? What if it's null? Probably means it's a new object. Let me adjust this. My notes are running off the page. Okay. So if that's the case, I'm going to say I'm going to grab, say, employee to save is a new employee. And what I'm doing here is I'm making what I call a copy or a deep copy. So that way, whatever somebody passed in, I'm not messing with their thing. I'm just grabbing the data out of it to make a new object. And what I'm going to do, because I'm going to do this, I'm going to take that newly created object and I'm going to set its ID. I need to give it an ID before I take it to CockroachDB. And so I'm going to use the UUID's built-in random UUID generator. Now I can go open this up in the IDE, and it actually, if you look up in the top left, you can see I'm inside the JRT. You know, this is a component of the JRE. And this is driven by the UUID specs to sit there and bake a new UUID from scratch right here. So now my new employee to save object has both the supplied name and role, and it's got a fresh UUID. And with that, I can use JdbcTemplate. Now, JdbcTemplate doesn't have a per se save operation. It has what's called an update operation. So it's with update that you can issue changing activities. So here I'm going to do an insert into employee, and I'm going to spell out the roles, and then I'm going to do the values. And notice what I'm using here these are named attributes. Remember how we talked about, well, I should say they're named parameters. That's why I'm using the named parameter JdbcTemplate. The old standard would have been to do this. This is what JDBC started with, is this mechanism. So instead of that, I'm using named parameters because I like clear verbosity. Now, what's missing with the update operation is that I need incoming parameter sources. Now, I could sit there and actually, there's multiple ways to do it. If I open up the specification, the simplest operation to provide is you feed it a map of string to values. It says here string comma question mark. So you could feed it a map of any value type you wanted mapped to a name. It's name to value mapping. We can do that, but actually Spring, remember mentioning Batman's utility belt? Well, there's something called a bean property SQL parameter source. I'm going to finish typing it and then we'll talk about what that is. And then we're going to fix this. Let me fix this here. There. Okay. So I don't know. One of the old-timey jokes out there is that Spring always has these very long-winded named classes. And I think there's a website. I think there's a generator website you can go where you click it and it's generating random things. But it's not hard to figure out what this thing is doing. It's a utility class. It builds a parameter source. What's parameter source? Parameter source. Well, SQL parameter source is an interface type inside Spring's JDBC module. And it's a container for a value that you're feeding to a parameter for JDBC. Okay. There's a value and then there's a SQL type. And the whole idea is it's supposed to be able to look at the value and extract the type so it can help you along the way. This is a SQL parameter source, or in this case, you could say multiple parameters. And what this one is this uses Java's bean property convention. Okay, so in Java beans, Java beans. What are Java beans? Do people even talk about this anymore? Fundamentally, if you have getters and setters that follow the standard convention with Java, you have a Java bean. So it's saying, hey, utility class, just look into this object, find all the getters and use them, and then you can extract. It also correlates with the name. Get ID maps to the name ID. So if I use the names here in the declaration and it matches the Java bean convention, this thing will automatically glue them together. And so that's really handy. So this is an insert operation if we don't have an ID value presented. What if we do have one? Then I'm going to do a different operation. It's still going to be an update. In this case, I'm going to do it's still going to be a JDBC update. And in this case, I'm going to make it a SQL update. I'm going to SQL update the employee table, set name equal to name, role equal to role, where ID equals ID. I mean, this is one of the beauties to me I like about SQL. It's kind of straightforward what's going on. And what do we do in this case? We need to provide it the parameters. So let's use that bean property SQL parameter source again. Now in this case, we're not altering or changing, I don't know why it does that. We're not changing somebody's incoming POJO. So there's no need to make a clone copy of it, a deep copy, if you will. So here I've done a save operation. We're either going to insert if we don't have an ID, or we're just going to issue an update if we do have one. And this gives us our save operation. Now what I want to do is implement one more JdbcTemplate operation, and then we can hook it into a web layer, which we haven't even touched yet. And then from that point on, we can decide what are we going to do next. So if we're going to be stuffing data into the database, we need to get it out too. So let's create a getter, if you will. Now let's do a find all. Find all is the hallmark of demo code, but something I would ward against if you're actually building a production application, because you don't want to fetch back 10 billion rows now, do you? So I'm going to return back a JdbcTemplate, but I'm going to do a query operation. So I'm going to do select star from that show. Okay. So convenient that they named that operation after our show. Okay. And this time I'm going to use, let me type it out, and then we'll talk about it here. Oops. Okay. Let's put some more. I want to push this up on the screen a little. See if I can fake it up here. Okay. So here, this is I don't know how to get it much simpler than this. So with JdbcTemplate, what we have access to is we're going to do a query operation. Now, this query, you feed it two things. You feed it your SQL statement. In this case, in all these cases, I've been using the Java's latest multi-line feature support. This used to be a lot uglier when we didn't have multi-line strings. So I'm typing the query. I own this query. And the fun thing is, SQL is not that hard. I've met plenty of business analysts, program managers. I've heard of judges in court cases that went and learned how to read SQL. Okay. But the other piece of that is this is what we're going to select. We get back a result set from JDBC, but then you need to iterate over it and convert it. And this is where this part comes in. JdbcTemplate has what's called a row mapper interface. I'm going to open this utility class up, and we're going to find this row mapper interface. And it's this tiny. It's what's called a SAM call. What is it called? Single action method. It's an interface, and it has one thing: map row. It's handed a result set. You know, the result set can have multiple rows of data, and it's given a row number. In this result set, map row 8, that kind of thing. And then this is actually strongly typed with generics and hand back whatever that T is. In this case, an employee type. So the idea is you can go write your own row mapper and use the result set APIs of JDBC if you want to. But Spring, the good people at Spring, in the same module where JdbcTemplate lives, they created a bean property row mapper. Basically, do you want us to do it for you using the same convention that we used up here to create a parameter source? Use all those getters and tell them what type it is. You got to in Java we don't have reification, so you have to give it the information this way. So it's okay. Now we know what type it is, so we can act on it and have it iterate over the getters and basically convert each column using this and res up employee. In this case, JdbcTemplate will then collect it together and turn it into a list. And that's it. We now have a saver and a find all, and we're able to get moving at building a web layer. And it's really not a lot of code. All right. I don't know if we had comments flying in or not. It looks like we don't have any comments today. So if you're getting value out of this, go ahead and smash the like button, and let's go build an API controller. How about that? So we've built this a service layer that's acting like a repository and doing stuff for us, doing JDBC calls to be specific. Now let's create a REST controller. And let's build it up on top of that employee repository. And in this case, with the REST controller annotation, that tells Spring Boot, hey, don't forget to res up this class and register it with the servlet container, okay? Or, well, not with the servlet container, with the servlet dispatcher. I'm trying to remember the exact name for that thing. And the servlet dispatcher is what's hooked into the servlet container. So we need a find all operation. So we glue it in there, but we need to add list to the type because there we go. And then we need to map it. And this one, there's no arguments. So I've got the thing to fetch back the data, but we need to initialize. We need to load some data. So for the other half of that, for a nice demo, let's create a database loader class. Oh, wait a minute. Yeah, I want this to be a configuration class. Okay. So let's call it a init database. How about that's an original name? Oop. And now what do we got here? That was a lot of typing with like very little action. So again, we need to give Spring Boot the signal of what to do with this class. So this class is going to contain an object that's going to do some setting up for us. And to be specific, what we want to initialize is this thing here called a command line runner, which if you open it up, it's another one of these single method interfaces. So a SAM in Java. And it basically has one operation, run, run this chunk of code. This comes from Spring Boot, okay? And it says, basically the paradigm is when Spring Boot starts up, once it's up and ready, it looks for any of these command line runners and then it runs them. Now, you don't want to try to have one command line runner coordinate with another. There's no guarantee of the order they're going to operate in. But if you want a chunk of code to run after the boot app is up, this is your hero. So we want this is a bean definition. We want to create a command line runner and register it in the app context. So we put a bean annotation. This tells you that this is a bean definition. And when you have bean definitions to tell Spring Boot that, this is a configuration class that contains bean definitions. It doesn't matter what the name of the method is. It could be gobbledygook. It doesn't matter. It's going to run it anyway. This is for our benefit to tell me what the point of this method is. It's to init the database. Bean definitions can have inputs. You can say this bean definition requires a bean of this type. So this is signals to the application context controller that is managed inside Spring Framework. So it says before you run this bean definition, you better have run that bean definition. It gives it a declarative sense of order. And then here what I'm doing, this is just a Java 8 Lambda expression here, which is one argument in. I happen to be calling it args in a plural sense, and the output is an operation. And this basically will get, I could do it like this. Return, let me do this here. Return new command line runner. And then, do what you want inside here. But you notice how it's kind of grayed out when you have something like that. Java, you can just flatten it into a Lambda expression. So with that in place, I'm going to do a save operation, and let's create our staff here. Frodo Baggins, ring bearer. I'd say we need some like Lord of the Rings music playing in the background, but then our channel will probably get hit with a copyright strike, so we don't want to do that. I may have to find out if we can get some can we get some majestic music to play in the background while we're doing this? Gardener. Okay, so here we have something to initialize to set up the database. We set up the database earlier. Here's where we're initializing it with content. Now we should have it where the schema script is getting run. This will drop and then recreate the employee table. On startup, it should then use this operation or these operations to insert the data. And then we should have this API controller up and running to actually fetch back data. So we now finally have an app. Let's try to run this and see what we got. And we'll find out how many typos I made along the way. I'm going to pull this up here. Now I like going to a terminal window, but it's kind of hanky if you're in a live stream. So it's easier if I can do it all from the same window. So let's scroll up to the top here and see what we got here. So here's our fun Spring logo. We're running version 3.4.2. Here we got, this is using Apache Tomcat. Now we notice here, here the connection pool is started up and it's using, here, look at this, added a connection, PG connection, Postgres. Executing SQL script file, it tells us what it's running, schema.sql, and it's running the drop table, create table, and it's done. And now Tomcat's up and running on port 8000. And then we can see here it's doing insert operations. And this is because we turn on all the log levels. It's setting the 3 parameters, you notice here. So we've got all this stuff here, parameter value class is a Java utility UUID, SQL type unknown. Okay, maybe you can't tell at this point, but we'll see what happens. Frodo Baggins, ring bearer. Then we see our next insert statement. We have Bilbo Baggins, burglar. And then finally down here, we have our third operation, Samwise Gamgee, gardener. So we're up and running. What can we do here? Well, let's go and look at that API controller we built, okay? Okay, let's check out localhost port 8000 API employees. And see what we got here. There's a lot of info up here. This is part of the song and dance of just HTTP calls. These are all the headers that got sent and the operation. So it did our get call, host, user agent, and then here's the response. We got handed back some JSON, and then we got this thing. Okay, what is the story? We're going to figure this out. And I'm gonna run it through JQ, my favorite tool, to pretty it up. So we got a 500 error. So what happened? Let's dig in and find out. Okay, so what it's saying here is you need an empty constructor call. There is no empty constructor call. Where did that come from? Well, let's go back in here and look at, let's see, where's the people that touch the database? All the connection to the database happened in here. So either it was this operation where we did an insert. Well, this one inserted and we already had an employee object. So this was doing an insert operation. And this one's doing an update. However, this is the one where we're selecting from the database first and coming the other way and trying to res up an employee object. So it looks like this thing needed to create, according to the Java Bean convention, needed to be able to create an empty employee object and run all the setters on it, which sounds like it needed an empty constructor call. And if we go back to our Pojo definition, we don't have an empty constructor call. That's what we need. So let's go and define that. And I don't, let's see, let's make it protected. I want to make it where in general, I don't want my code to use this, but it may be needed by that bean property row mapper. So what I'm going to do is let's restart the app and then let's see what we get. Okay, that was fast. Okay, let's flip to the terminal tab. Let's run the same curl command we just did. Poof, we got our results back. So here's our 3 entries. They happen to be in no particular order. Well, that's not entirely true. They are in a certain order. Now, if I go back here, let's see. The select operation is select star that says, give me all the columns from this employee. There's no order by clause on this. So in SQL, in the SQL spec definition, if you don't put an order by, basically the carrier, the database provider, gets to return the rows in whatever order it wants to, whether it's actually done any immediate ordering. Now, what CockroachDB does, it's going to fetch it back to you using what's called the primary index, because we don't have any indexes on this table at this point in time, and so it's gonna go and it's gonna find which. It's in this case for select star, it's going to go hit all the ranges. I talked about how CockroachDB splits your table up into chunks and ranges and replicates them across the enterprise. In this situation, our entire data fits in one range. So there's one range that it's going to hit in this case. Now, if this had 10 million rows, we'd be talking a different story. But it's going to go to the range that has the rows, and it's going to use what's called the primary index. The primary index is automatically created. We haven't created any secondary indexes, and we really haven't dove into talking about secondary indexes yet. But there's a primary index based on the primary key. The primary key in this situation is the ID column. And what's the ID column? It's a UUID. So if I look at the UUIDs, if I look at the ID column of this output, these rows come out suspiciously ordered by primary key. You notice how this ID 4 is less than, the 4 is less than 7, and the 7 is less than C from a hexadecimal perspective. These are just a series of hexadecimal digits. So CockroachDB has got the way it's storing the content under the hood. It's actually a key value stored that it's using as the actual concrete storage device. So what it's done is it's not exactly the key is the key of the underlying data store is the primary key in the table. There's a relationship there. It reads something like /table name /column name, and then the actual value that UUID maps onto a hashed value of the entire row of data. And then it's all encoded in a particular format, but essentially it's sorted by the primary key. So if we don't do any extra ordering by, that's the order you get it in. It's pre-sorted so that the key value store can search very quickly. It can use a binary search and find the row that it's looking for quickly. So that's just the reason why it happens to come out sorted. Now, if your data starts to cross into multiple ranges and CockroachDB is having to go grab different ranges and glue them together, the chances it's going to be ordered like that kind of falls apart. So if you want to guarantee any particular select operation is in a certain order, you need to use an order by clause. Long story short. Now let's go. One of the things is let's pause for a second. If you got comments, post them. This is lots of fun stuff here. But one of the things that I had gone and I did some digging when I made a video like about 3 years ago on JDBC stuff was I knew JDBC had been around for a long time, but I wasn't sure how long. So I went and looked it up. It's been around since 1997 with version 1.1. It came out in February that year. So JDBC has been around like that's when I joined the workforce as a professional coder was in '97, and so JDBC is a long-standing standard that's been around for a while, and it as the saying goes, it has all of its own warts. So if you've ever used JDBC directly, it's tough. To say the least. Part of it is the way JDBC built is it's a standard that's built for both drivers, the people that write drivers, like the Postgres driver, the MySQL driver, they use the JDBC spec to build the driver, but it's the same interfaces that application developers use. And there's some places in there where the spec is a little bit higher than a driver needs to be, or in other places it's a little bit lower than where apps need to be. And that was something that was factored in when we came up with the R2DBC spec back when I was on the Spring team. In that case, we kind of defined two different levels of separation. Like here's the layer for app developers, but here's the level for driver developers. So there's some bits of code that you find out have to be re-implemented over and over and over in every driver because of that. And there's other places where you're an app developer and you're like, why do I have to fiddle with this? I don't, this aspect. So it's like there's a lot of rules and conventions you need to follow if you're going to work with JDBC directly that kind of earns it, a black eye here and there. And part of why I was really attracted to JDBC template is because JDBC template's like, let's put a nice layer over all of that aimed at the developers. Okay. JDBC template's built for developers. So you can go in there and actually work with from an application perspective. So in JDBC in any relational database, the convention is I need to create a connection. I need to open a cursor. I need to issue my SQL statement. I need to iterate over the results. I need to, map stuff. I need to close the cursor. I need to close the connection. And if you leave any of those housekeeping steps out, you've got a leaky situation. It's a bugbear process to follow. And what you find out is after you've written 200 queries, somehow the database, every 6 weeks, the database keels over, or the app server it's running on keels over because you were leaking connections. So you track it down, you fix that one query that you forgot to close the cursor on. And then 6 weeks later, it happens again because there's another query that you missed. And JDBC template takes that away where you don't have to deal with that. So instead with JDBC template, you get to focus on, I'm writing the select and here's how I'm processing the results. The rest of the life cycle is managed by the utility.
Greg, I want to add something for our viewers. As you can say, or as you can actually tell right now, that every step that you normally do for a kind of a JDBC connection, it's a lot of stuff, right? That's the Java world. But with Spring, with the JDBC template, it's minimal, right? Now, if we are talking about just Spring applications, normally you need to do these steps. So if you're a Spring, just a Spring, no Spring Boot, just a Spring. With a Spring, you normally require your dependencies. You're required to wire up the data source. You need to wire up also the entity manager factory, the platform transaction manager that you're going to use. And for example, in the entity manager factory, you normally put a vendor if you're using JPA or you're using any other particular manager factory for these kind of scenarios where they need to open a session, they need to start part of the transaction with your transaction manager. And of course, you need to also wire up your JDBC template or your name parameter JDBC template. Then in your code, now that's when you inject and use it. Now with the Spring Boot, something that actually Greg did in this particular demo, the only step that you require is just to add the dependencies. Practically, Spring Boot wires everything up. Remember, Spring Boot is an opinionated runtime that allows you to practically start as fast as possible. And as you can see, the only thing that Greg did was just to wire up the name parameter JDBC template. That's the only thing he did, and practically just focus only on the SQL business, right? So that's the benefit of using a Spring Boot. Again, for the uh, kind of a seasoned developers, right? With the Spring, remember you need to do a lot of steps in order to practically did what Greg just demo. But with the Spring Boot, it was just the dependencies and just the inject and just use the name parameter JDBC template. So amazing to do things very quickly with the Spring Boot.
Yep. I think it was Josh Long that had said, maybe I could be wrong on this, but I think he was the one that had said it's like pair programming with the Spring team when you're
Yeah,
doing that, and it's like major leap forward in functionality. Um,
yeah,
so one of the things I wanted to step back and look at this is let's look at that. Let's look at all this from a more holistic perspective. Um, so we've done some other shows. We've talked about things like Spring Data JPA or Spring Data JBC, where uh, we're leveraging some stuff here. Those are tools to help to make it to say, okay, so we've pulled it up to where, okay, with Spring Boot, I don't have to define every component. Spring Boot comes with pre-configured components to do all the infrastructure. So what I'm doing with JDBC template, it lets me get above that all that JDBC nitty gritty. Um, I feel like it would take me 3 times longer to write out that what I just did if I used pure JDBC APIs. Now, if you want to do that, fine. If you have fun with doing that, that's fine. It's a lot of stuff to keep track of, a lot of bookkeeping, if you will. But with JDBC template, I can focus on this is the operation I need to do, and here's either the inputs or the output, the format of the outputs that I want it to do. So people step onto even higher level toolkits, like Spring Data stuff, for example, to be like, well, in this system, I got to write 200 operations, and like half of those are very boilerplatey. There's not a lot of thinking to that. So they'll do that, and then it's going to focus on, well, the other half are now those queries that are page long, or a 5-page long query, or a query that I'm having to join 20 different tables. When I was with the Spring Data team, I mean, some of the stuff we would share would be like, if you're joining like 3 or 5 or 8 tables, it's probably the signal that you just need to write the query yourself instead of depending on the shortcuts the toolkitting offers. So one of the things is, if a tool is writing the query for you, it becomes trickier for you to optimize it. Here, you own all the queries. You can go optimize them. You can go, we talked about the stuff gets wrapped in transactions. You can wrap it in logging or performance calculations and figure out which query is eating up all my time so I can focus on optimizing that query. So, we're trading convenience against, how much, what I'm going to do for, this is more convenient to write, or this is more effective. I can fine tune this. So there's performance versus convenience. But then we have other stuff at hand, like what's the overall throughput? If I'm as I move at higher and higher levels and in increasing layers of abstraction, it's not free. There's costs to using that. So I actually had an opportunity to chat with one of our customers when we were on site last year out on the West Coast, and we were presenting our training content. But during a break, I asked them because they had already been using Spring to write operations, and this was a transaction that had 10 operations within the transaction it had to do, and the total budget for the entire transaction of 10 operations was 300 milliseconds. Not 300 seconds, 300 milliseconds. They had to achieve their results. And I was asking them, what are you using, Spring Data JPA? And they said, no, we're using JDBC template everywhere. They couldn't afford the cost that came with using a higher level thing. They were doing JdbcTemplate. They were optimizing the heck out of those queries. And with JdbcTemplate, you're right there. You're able to, you can sit there and say, well, should you be using pure JDBC? It's doing some stuff there. Well, I used the bean row mapper on that. I didn't ask them what they do for mapping. They may be using the JBC stuff in the callbacks to actually get the exact POJO types. The other thing is if you're going to fetch something and like you're fetching an entity type, what if this entity type has 200 columns, but you only need 3 of the columns? Well, in SQL land, the recommendation is only select what you need. Okay, only select the 3 columns. Now, depending on what you're using or what you're doing, that can make a difference, or it might not. But always declare what you're doing. And if we were to use the bean row property mapper and the entity type had 200 fields, it's going to run 200 getter calls. That ain't free. It may not be much, but it depends in your situation. But in that situation, I'd write a custom row mapper. I would only get the 3 columns that I needed, and I'd only set them. And the other thing, you could measure that and see, is it a difference or not? It may be microseconds what the difference in that part is. But they're needing to optimize every single thing, and the JdbcTemplate gives you what you need to do that. The other thing they needed to do was control where the transaction boundaries were. So with Spring's declarative transaction support, they have, which we haven't even shown in this demo, is you have the @transactional annotation on the operation. So they could define that and manage that. And they were actually using Spring's retry feature. So they defined it with retry options, because the other thing we haven't talked about here today is in CockroachDB, we default to serializable. With serializable, you can have, if you have a collision, 2 different people are trying to update the same row and it sorts it out, you can get a retry exception, which says, well, that the state of the situation changed since you started the transaction, and we can't guard you against any data anomaly, so you need to retry again. So it's easy to put a @retry annotation on a transaction and say retry it 3 times and use an exponential backoff algorithm, all declaratively. And they were using these features, and this actually works so that they could meet their budget. So, these are some of these huge operations out there. Still reach for JdbcTemplate, because it's the thing that I think the cost difference, the performance difference between JdbcTemplate and raw JDBC is probably almost next to nothing. I think it's don't take my word for it. Go test it out. Go try it out and see if there's a difference. But no more is there any kind of entity manager like JPA has. There's no entity manager. There's no secondary cache that the entity manager comes with and is managing. There's no dirty checking algorithm to see when to do flush operations. Instead, you're in the driver's seat with JdbcTemplate, and that's what it's really good at. So there's no confusion about, is somebody else involved here. When you work with JPA, you run into scenarios of, okay, I need this operation, I need it to flush now. That's why in JPA we have save and flush. It's like, this situation, I know it needs to flush the results, and if I don't issue this flush now, it causes issues down the chain. JdbcTemplate, you don't have to think in that terms. You just think about, I'm doing this operation. Is this operation inside a transaction? And you can define where the transaction boundaries are with ease. I do want to let you know that today's episode of Select Star is brought to you by Cockroach University. If you want to play around with CockroachDB, get your hands on a real operational copy of it, you can go either scan the QR code or visit university.cockroachlabs.com. And guess what? It's totally free. You can check it out, and you can have a little fun there and find out. And there's some really great it's multiple courses in there. One of them is a 3-part app developer course, where you get to play around with CockroachDB, then eventually with the Java app on top of CockroachDB. But there's more advanced courses. We've got things like, you find out about CockroachDB's multi-regional support and being able to have data that follows certain geographic rules. So you can have some of your data, if you have map address based data, like some food brokerage service where you order food and it's brought to you, If you're in San Francisco, your app doesn't need to be showing restaurants in New York. Whereas if you're in New York, you don't need to be showing the restaurants that are in San Francisco. That kind of geographical data. That's a baked in feature that CockroachDB comes with, and you get to play around with it to learn what that really is in Cockroach University. And it's really pretty cool. I want to invite you to hit subscribe and ring the bell so you can catch it when we have our next episode of Select Star, and leave it in the comments what you want us to talk about. We've kind of launched the show this year, Felipe and I have, with going over some Spring content, but this is not a Spring Central show. We want to talk about everything you can possibly learn with the database that you just can't kill. So hit the subscribe button. Is there anything you want to throw in here, Felipe, before we wrap the show up?
Yeah, just to kind of follow us, and very soon we're gonna talk about test containers. That's something that I wanted to do and show the power of that particular technology that allows to do testing, so we can experiment with also the magic of a Spring Boot, trying to leverage all the probably kind of multiple steps in order to do data tests. But now with test containers, with a Spring Boot, you minimize that effort, and practically you have a 100% pure data tests on your projects, right? So that's something that we are aiming to do as well. And also very soon talk about more of the internals of CockroachDB and see how they manage certain aspects, right? Some of the key features of CockroachDB. So stay tuned.
All right. We'll see y'all next time.
This episode is over, but your learning has just begun. Visit CockroachLabs.com to find all kinds of content to expand your knowledge.